Hello everyone. In this video I'm going to be explaining the solutions of the questions in your workbook on page 30. So if you open your workbook you can follow the questions from page 30. So for all questions we are going to ignore air resistance and the gravitational acceleration will be 9.81 Newton per kilogram. This can also be written in meters per second square. So, in this first question, we have a projectile, a ball, which is kicked off the edge of a cliff as shown in the diagram opposite. Now, first thing you should see is that this is only a horizontal initial velocity. It's thrown from 80 meters high and it's going to land the distance away from the edge. 32 meters per second is the initial speed, which is only horizontal. So we're asked to calculate the time taken for the ball to reach the ground. And for that, I'm going to make a table of everything we know on the horizontal and on the vertical. First of all, initial velocity x in this question is this given speed right here. So I'm going to write that here as 32 meters per second. The vertical velocity in this question is 0 because there is no upward or downward component, so vertically the motion starts as free fall. Acceleration along the horizontal is definitely 0. There is no air resistance, so we have to remember that applies to all of the questions. We ignore air resistance in all questions. We do know that the acceleration along the y is downward 9.81 meters per second square. This ball is going to follow this path where it falls for a distance of 87 meters. So the displacement along the y is negative 87 meters because it lands lower 87 meters. This is the displacement vector for the y component, and this is the displacement vector over here for the x component towards the right, which is equal to d. So I will write displacement x is equal to d. This is everything that we know in one chart. So we make this chart to make sure that we use equations of motion using numbers from either this column or that column. So here's how it works. To calculate the time taken, how do we calculate the time taken? Do we use the x component information or the y component information? That's the first decision you have to make. And look at the picture. Look at this incident. The story goes, the ball has no change in velocity along the horizontal. And it can just keep going because there's no force acting on it along the horizontal. But in the vertical, there's gravity and there's a limit where it will stop. So the motion will continue until it hits the ground, which is limited by this vertical height. So I'm going to use the vertical components, and to calculate the time, knowing with all of these, think about which formula is going to help you. If you use S equals, let me write this in red, so here's the solution. I'm going to use S equals ut plus 1/2 at squared, and I'm going to make sure that I am looking at y components only, which means I'm taking values only from this column. So what's the displacement in y? Negative 87 meters. What's the initial velocity y? That's a 0, so I'm not going to bother with that term. I have a 1/2. Acceleration y is our good old negative 9.81. And we have the t squared. Rearranging this is going to give us 87 divided by 4.9 in the square root, which calculates to 4.2 seconds. So at t equals 4.2 seconds, the ball has reached this point. For part B, to calculate the distance marked as d on the diagram, now we're looking for d. Now, please realize that is now asking for some information along the horizontal component. So now I'm going to use only the values from the x-axis column. So I'm going to use, to find the d, I'm going to use the same formula actually. S equals ut plus 1/2 at squared. But now I'm using the same formula for the x component. So I end up using the formula twice in the same equation, but I use it for the vertical to find the time. And now that I know the time, I'm going to find the displacement using that, because what connects the horizontal and vertical components is always time. So I found the time from the vertical. I'm going to write d here because that's the name of the displacement along the x. Initial velocity x is 32 meters per second, so let's put that here. We multiply that by the time we just found, which is 4.2. Acceleration along the x-axis, the horizontal acceleration, is 0. So this time, that term drops to 0. And that gives 134 meters as the horizontal displacement in that answer. Looking at part C, to describe the shape of the ball's trajectory, it is a parabolic path, and the reason is there is no acceleration in the horizontal, but there is acceleration in the vertical, which means the vertical displacement will increase, whereas the horizontal displacement will not change each time interval, which causes the motion to be parabolic. The question has another part which says, if the ball were kicked with an initial velocity of 16 meters per second instead of 32. So the question now says, what if this initial velocity in the horizontal is half, not 32 but 16? That is the only thing the question is changing. So to answer part A, look at the solution of part A. Did we even use the value of the initial velocity in part A? We were finding the time, which depended on the solution for the time using the vertical component, because that was what limited the time to hit the ground. So I am going to realize that the horizontal velocity doesn't even affect the solution for the time. So the answer for part A is going to be the same. It will take the same amount of time to drop to the ground from this height, because height was the only limitation to determine the time. However, in part B, we used the initial velocity because we were looking at the horizontal displacement. So instead of 32, it's going to move with 16 meters per second for the same amount of time. And when you multiply that, you will get half of this answer, which is going to be 67 meters as the horizontal displacement. 2. A soccer ball is kicked with an initial speed of 32 meters per second at an angle of 35 to the horizontal. And determine the time, the maximum height, and the range. So, let's calculate ux and uy as usual. So ux is going to be 32 cosine 35 because this angle is to the horizontal. So if this is the initial velocity, that is the angle that is given. So ux is going to be the adjacent side. We use cosine. And for uy, we are going to calculate 32 sine 35. So that's going to be our numbers. Okay, the time before the ball hits the ground again. We said we want to make a table. So let's do that. We have an x and a y component. Our initial velocity, ux, will be the answer to that calculation, and uy will be the answer to that calculation. The acceleration along the x component is obviously 0, and the acceleration along the y will be negative 9.81 meters per second square. So just to add the numbers here, this is 18.3 meters per second, and 32 sine 35 is, sorry, that's 18.3 . 32 cosine 35 gives 26.2. So that would be 26.2. And that's 18.3. To find the time before the ball hits the ground again, first we're going to find the time to reach the top, because this is what the ball is doing. First we're going to find the time to reach the top. At the top, Vy is going to be 0 at the top. And that's what I'm going to use to find the time to reach the top by using this formula. V equals U plus AT, which is what we did in the free fall questions. This is now something I'm doing for the Y component only. So the V at the top is 0. The U initial Y is 18.3. And the acceleration is negative 9.81. This is going to give me the time to reach the top. So when you divide 18.3 by 9.81, you get, for the time to reach the top, 1.86 seconds. The total time, is going to be twice that, which is 3.7 seconds for the whole motion. So at 1.8 seconds the ball is here, at 3.7 seconds the ball is there. Now to find the maximum height, I'm going to use S. This is still in the vertical, this question, because it's asking for the vertical displacement. I'm going to use S equals ut plus 1/2 at squared only for the y component. So I make sure I highlight that for myself over here, and then go back to the formula and replace everything that I want to know. S is my question, so I can continue from here. Initial velocity y is 18.3. I'm only taking numbers here. So 18.3 times the time to reach the top, which is 1.86. I found that there. Plus 1/2 g t squared. So to clean that up, it'll be like that. And then when you calculate, this question gives us 17 meters. As that maximum height. To find the range of the ball, now this is a horizontal displacement. I'm going to use S equals ut plus 1/2 at squared again. But this time I'm looking at the horizontal because I'm solving for a horizontal. Well, I know that that is a 0 along the horizontal, so this is going to give me the range to be equal to u initial, which is 26.2, which is constant, times the total time, because I want to know the range all the way up to here, so I'm going to use the total time, 3.7, which is going to give me 110 meters. Describe and explain how your answers to part B and C would change if the effects of air resistance is included. Well, both would be reduced because air friction would act opposite any motion, so the maximum height would be less and the maximum range would also be less. So if you want to show that on the diagram, it would go up to a less height and it would end up landing to a much closer point, so both would be reduced. 3, we are now looking at the projectile fired at 25 meters per second at an angle of 42 with the horizontal and following that path in air. It starts from 24 meters high and ends up on the ground over here. We want to know the time of flight and we want to calculate the total range. So this is the horizontal displacement and the time of flight is the first question. So to find the time of flight, the first thing I want you to realize is that the vertical position of this question, of this story, is exactly the same story as number 15 on page 26 of your workbook. So I want you to take a moment to go back to page 26 of your workbook and review the solution of number 15, which we did in class before. And as soon as you see that identical from this point vertically, this is going up, come back down, and fall further from where it started. So the vertical dimension of this question will be identical to what we did in that question. So let's make our nice table. The UX is going to be 25 cosine, because x is adjacent to 25 here. This is UX. So I'm going to multiply it by cosine of my angle. This is going to give me 18.6 meters per second. And UY is that component which is opposite the angle, so 25 sine of our angle, which is 16.7 meters per second. Let's write them here. We start with a ux of 18.6 and we start with a uy of 16.7 meters per second. I don't have space to write the units here, but they are there. We know the acceleration in x is 0. We know the acceleration in y is negative 9.81 meters per second square. The displacement overall for the whole motion is right here, negative 24 meters. And the displacement overall for the motion is the question that we will figure out in part B. So I'll label it on the diagram. That is the R, the horizontal range. So to solve part A, we need to find the time of flight. Just like we did with the previous question, we can find the time to reach the top and then find the time of free fall after that. We can add the two, so let's do that. There is a shortcut, I'll show you after this, but you don't have to do that way. Let me show you this solution first. So to solve part A here, first of all, I'm going to find the time to reach the top. At the top, I know if I use V equals U plus AT for the y component, I know that at the top, this is a 0. Initially, that is upward 16.7. I know my acceleration is negative 9.81. So this is going to give me time to reach the top, which gives me 1.7 seconds. So now that I know it takes 1.7 seconds to come here, I want to know how much time it's going to take from this point. Now my initial speed is 0 and I'm falling from this height. So if I just know that height by calculating using this formula, S equals UT plus 1/2 AT squared for the y component. So using this formula for the first half, now that I know the time to get to the top, this height that I labeled on the diagram is going to be the initial y component velocity. Ay, ne yaptım ya? Times the time that I found plus 1/2 AT squared. This is going to give me 14.2 meters. So now I'm going to continue over here. I'll bring it back over there. To find the total height it's falling from, I'll do this 24 plus 14.2. And now I'm going to calculate with S equals UT plus 1/2 AT squared for the y component only, which I am doing from this instant to that instant. And for that part, initial velocity y is now 0. Displacement is a negative 38.2, and the acceleration is negative 9.881 t squared. So this time is going to be 2.8. And then the total time will be time to reach the top plus time to fall from the top. So my answer is 4.5 seconds total. To find the range, again, I am using one more time this good old formula, but now I'm going to use it for horizontal, which means I'm going to need to take values only from this side of my table, where acceleration x is 0. I know the total time, so this is my range, and my initial x component velocity is 18.6. 18.6 times the total time all the way to reach that point, 4.5 seconds, and that answer gives me 84 meters for part B.